This activity will help illustrate how the law of reflection works in practice. For this activity, you'll need your reflection template, which is linked in your assignment slides, a plain mirror, which is just a mirror that's flat, something capable of shining a single beam of light onto the mirror. I'm using a ray box, but you can use a laser pointer if you have that too. You'll also need a pencil and a protractor. You'll see that the template is set up for you to be able to shine a beam of light along a specific line. This line is called the incident ray. Notice that when you shine the light on the mirror, the ray will reflect off of the surface in a very predictable pattern. With a pencil, roughly trace the path where the beam, called the reflected ray, travels. We will draw over the line with a straight edge after. And repeat this activity with the other 3 incident rays. Once you have the roughed-in reflected rays, use a straight edge to define them more clearly and accurately. Once you've completed your experiment, your template should look something like this. Our next step will be to draw the normal line at the interface between the 2 rays. This line is drawn at a 90-degree angle from the reflecting surface, so use a protractor. Now we measure the angles. These are always measured from the normal, not from the reflecting surface, which is why the bottom edge of my protractor is along the normal line. The angle between the normal and the incident ray is the angle of incidence. The angle between the normal and the reflected ray is the angle of reflection. And now we will repeat this process, drawing the normal and measuring the angles of incidence and reflection for each of our sets of rays. Notice that the values of the angles are very close together, almost identical. Almost because experimental results can have some minor errors in precision, but you can see the overall trend. It is this trend that has led to the development of the law of reflection, which states that the angle of incidence will always equal the angle of reflection. Light will always behave according to this law.